take a look at the human impact on the hydrological cycle. Specifically right now, let's talk about the influence on precipitation. Now, humans do have some sort of influence on precipitation in the way of cloud seeding. Now, cloud seeding is where a chemical such as silver iodide or ammonium nitrate is actually introduced into the atmosphere, which stimulate water droplets to form. Now, think of what this kind of chemical is. Silver iodide, ammonium nitrate. These are actually chemicals that are fairly toxic if you were to actually ingest them. However, we're introducing them into the atmosphere, which stimulate water droplets forming. So it's not actually involved on humans. However, keep in mind that we are introducing this into the atmosphere. Now, cloud seeding has increased precipitation rates of about 10% to 30% on a short-term basis in some areas. This often increases precipitation also in urban areas by as much as 10%, partly because of the pollutants that are currently in the atmosphere, turbulence, and the heat island effect. So cloud seeding is actually something that humans do in order to allow precipitation to happen in certain areas. However, keep in mind that by human influence on particular areas, we might also inhibit precipitation in other areas. So if we're adding precipitation to one area, we might be decreasing it in another. So the human activity on precipitation, we have to be very careful about what we're doing, because in some areas it actually might be a detriment more than it actually is a good thing for that particular area. Let's take a look at the human influence on evaporation and evapotranspiration. Now remember, evaporation and evapotranspiration involve the evaporation of water, basically where the water is changing from a liquid to a gas. So in evapotranspiration, this is where the liquid on plants is actually being evaporated. So if we look at the construction of large dams, now this actually increases evaporation, partly because we have such a large store of water now on the surface. So in areas that did not have a large store of water previously, we now do have a large store of water. So this will increase the evaporation rates of this particular area. Now there are certain things to decrease that evaporation rate. Water loss can be reduced by chemical spray on the water, building sand-filled dams, or even covering these dams with plastic. Now keep in mind once again that these are human activities being placed and forced on the environment itself. So we have to be very careful about what we're actually doing to the environment. We have to think about that. Imagine this chemical spray that we're spraying on top of this water. There are living things that are going on in this particular place. They live, they breed, all sorts of things. So if we are spraying these chemicals onto it, how are those chemicals affecting those plants, those fish? Same with covering dams with plastic. Now we're inhibiting a lot of the birds in the area, a lot of the amphibians or the reptiles that might actually live along these the banks, to getting to these particular fish and the plant life that they might use to survive. So we have to think about the entire ecological system when we do some things like this. Urbanization also has an effect on evaporation and evapotranspiration. Because we create these cities and these concrete jungles, we typically deforest, we get rid of all the land, all the trees and the plants in certain areas. So the lack of vegetation in these areas will decrease evapotranspiration. Central Park in New York is great because there's all these trees and greens and vegetation and life that lives there. However, in the rest of New York City, we really don't see a lot of vegetation. Now, because we have these concrete jungles, we also see a lot of higher temperatures, and thus we get a lot more increase in evaporation of those surface stores. And because we have the sun beating off of the concrete, it's basically being reflected. So we have a lot of heat generated, and we have these surface storage of waters that we have an increase in evaporation on these particular things. Now if we take a look on the human activity or the influence of human activity on interception, that also causes some sort of imbalance, perhaps, that's going on in the environment. So remember, interception is basically where plants and vegetation will intercept or will take in some of that water from the precipitation, slowly allowing it to move down the stems and the leaves, kind of like the drips off of trees, down the roots, and then taking it in for themselves, sometimes storing it for themselves, and sometimes maybe just holding it onto their leaves. Now, understand that most of the vegetation that we come across in the nation is not natural vegetation, meaning that it's more farmland or area of deforestation. So we have a lot of farmland where, yes, we have this vegetation, but it's not necessarily natural to the local ecology. So corn and wheat, these are not things that are natural to the Midwest. They happen to grow very well there, but it's something that humans have planted. Because of this, it leads to a lot of bare soil. So if these things are in rows, we have a lot of soil that's kind of just exposed in between the rows of corn and wheat. So we see a lot of overland flow because there's no plants that are really there to capture that precipitation. So the interception loss is extremely high in this particular area, partly because of this natural vegetation not being there. And when we're talking about deforestation, we're talking about just leveling whole forests and whole areas of trees and different kinds of plant life. Now this also leads to a reduction in evapotranspiration. Because those plants aren't there, we're not seeing that transpiration coming from those plants. It could also increase surface runoff. We don't see the plants there anymore to absorb a lot of that water that's running, that overland flow. We might see a decline in surface storage. Notice the typo in decline. The decline in surface storage. We might also see a decline in the lag time. Think about your hydrographs that you drew. So if we have a lot of deforested areas, or not a lot of areas that have plant life, that lag time between the highest peak in rainfall and that highest peak of that, basically the peak discharge of the river, that's going to decline. It's going to become less. So you have less time to evacuate areas or less time to kind of clear out and be safe. We see a reduced interception, so our interception loss is really, really high. And then we have increase in soil compaction as well. In certain areas, like areas used for farmland or for grazing land, we see a high rate of soil compaction by the grazing of cows and different kinds of animals. As they step on the ground, they're compacting all that sediment together. And because now that sediment doesn't have this space in between each of the little grains, they're all compacted together, kind of like a trash compactor. Now there's less space for that water to run through. So this is going to cause a lot of that interception loss as well. Also, we see the influence of human activity on infiltration and the soil water. And this is the infiltration, remember, is sort of like when the rain hits that surface, it's the amount of time that it takes in to be soaked into the ground. Same with soil waters, that stuff that kind of moves, that through flow right underneath the surface. So certain uses of the land that humans sort of use the land for. So certain land use changes that humans have done over time have changed the way that water is infiltrated into the soil. So we've already talked about urbanization. Urbanization, the creation of cities, creates these impermeable surfaces, your concrete jungles. So that concrete prevents the water from being infiltrated into the ground. So we have a higher rate of overland flow. Deforestation also reduces that amount in the type of vegetation, again reducing infiltration, like we've already discussed with some of the other types of vegetation loss. And then we've also the building of larger and larger dams will also increase the amount of surface storage. And we've already talked a little bit about how this can create higher levels of evaporation. So all of these things are actually reducing the amount of water that is going into the ground, which means that we have less and less groundwater, which is something we'll talk about soon. But keep this in mind that land use changes by humans are reducing the amount of water that's going directly into the soil. Also, the land use practices that we go through, that we do every day, such as grazing and plowing. Plowing will actually create more air and kind of aerate that soil, which allows more infiltration. However, grazing will not, and we discussed that in the previous slide when we talked about soil compaction. One other thing that land use kind of leaves behind, if we have poor drainage in certain areas, this leaves different salts behind when it evaporates. And those salts will be part of the groundwater. It can infiltrate the groundwater, and then that groundwater is unable to be used because it's too salty. So we have to be very careful around the farmlands. For proper drainage, we want to make sure that proper drainage goes through so it doesn't leave those salts behind when the water eventually evaporates. Finally, we've discussed dams already before, so some of these things might sort of sound familiar to you. But dams are a huge thing that humans are increasing every single day. We tend to build larger and larger dams each time we're building one. I believe somewhere I read the number of dams that we are that are increasing in the world has gone up, like thousands fold. There's tons more dams in recent years than there have ever been before. Now, dam building will lead to an increased store of surface water. We've already discussed that. So think about all your dams, which we use for certain activities like power production and other things. However, it's increasing to these stores of surface water, which again increase the evaporation. Not a lot of water will be infiltrated, things like that. It'll decrease flood peaks. So it actually changes the river morphology, if you will, and then it's not able to flood at certain times. The Nile River is actually something that that we see with the Aswan Dam has changed the flooding of the Nile River, which is something that is naturally occurring, which creates the floodplains and allows that to have all this nutrient-rich soil. Now, without that flooding, there is no more nutrient-rich soil. So the agriculture around the Nile River has actually gone down in recent years due to the Aswan Dam not allowing the Nile River to flood properly. We see low flows in rivers. So the rivers that feed into these particular things are not flowing properly, and that's changing the entire ecological system around those particular rivers. We see decreases in sediment yields, which could possibly change deltas like we've talked about. It could change the morphology of waterfalls and gorges and things like that. Decreased losses due to evaporation and seepage, and this leads to changes in temperature and water salinity. So if we have more evaporation, it leaves more salts behind. That water salinity will change. We get more seepage into certain areas that might not have seen water before. Certain temperature changes, because as you'll see, it also can change those local climates because we have more water. So that's going to change locally, it's going to change the climate in the particular area over a long period of time. With dams, we can increase the flooding of the land, trigger earthquakes. There have been tons of earthquakes that have been found in China. Salinization, I've mentioned that, as the increase in evaporation leaves many salts behind. And it actually declines surface storage in areas without the dams, because now the water is basically all stored in one particular spot. So you see that human activity influences all these different parts of the hydrological cycle, from precipitation all the way down to infiltration. And in the next video, we'll actually talk about more influences of human activity on groundwater.